Finally, let's take a look at the last example about the recursive function. This time I want to use binary search to show you the comparisons between recursive version versus a non-recursive version. And of course, for the binary search, we discussed this in the very beginning of the semester using a loop function. So let me try to refresh your memories. For the binary search, we have given array A and we try to find a value, say X. So what we will do is that we will try to find the middle index and then we search either the left side or the right side. The final output would be the index of the place that stores the value X that we are interested in, or indicating that the value is not there. So we try to starting with, for the loop version, we're starting using the left side leftmost index 0 as the left side or the low, and then for the highest index indicating it's the high, we sums the two values up, integer divided, find the middle index, and then compare the value, try to search either the left side or the right side. In this case, of course, we need to search on the right side, so we will change the left index equals to the middle index plus 1. So that what we will see is, in this case, we will have the three different case scenarios, and then mapping either to look into the left side or the right side, or actually we found the value. So in the case of this one, we look into the integer division, and then basically we will start searching from the index of 5 to index of 9. So between these two, we again finding the middle value. So 5 plus 9 divided by 2 equal to 7. And then we will compare this value, 18, with the X value, which is 16. We'll understand that we need to look into the left side. So when that is happening, we will change our high to middle minus 1. So that's how we'll be able to search the left side. And then we would look into the middle value, finding the index of 5 is actually storing the value of 16. So we hit the third if statement, indicating that this is where we are interested in, and therefore we need to return the index of 5. That's what's happening about the loop version of the binary search, so that we would define low and high, and then inside of the loop, as long as low is less or equal to high, we will continue doing this. If this is not true, indicating that the value is not there, because low should always be less or equal to high. Otherwise, indicating the value is not there. And inside of this scenario, we have case 1, case 2, and case 3 to help us identify the values we are interested in. And you can see that this is using a loop version of the code. It is totally possible to convert this piece of code into a recursive fashion. So let's take a look at this one. For changing that into a recursive version of it, what this function trying to do is, first of all, you will take basically 4 parameters. However, the first parameter is actually the vector itself that stores the data. The X is the value that we are looking at, and therefore if you try to define these two values, the array and the X value in a global way or in a different fashion, the most important 2 parameters are actually the low index and the high index. So as long as low is greater than high, this is using the same idea. When low is greater than high, that's something wrong, indicating the value is not there compared with the previous version of the code. Low always need to be less or equal to high index. If that's not the case, then what we're going to do is that we try to find the middle value, low plus high divided by 2, and then if that index, the value store of the index is actually less than the X value, then we need to search on the right side, and therefore we will call, this is the interesting part, call the binary search function recursively, passing the same vector, the same value we are interested in. We need to change the low index become middle plus 1. So it's actually the same idea with what we said earlier. The only difference is that we pass this parameter into a recursive fashion. Of course, high, we don't change the high index over there. If that's not the case, the other case, then we need to search on the left side. Then we will call call a recursive function, still passing the same vector, same x, low stays the same. Now we change our high, become mid value -1. So it's case 1, case 2, and of course the case 3 is return the middle value, indicating we found the value. So this is actually the code for a binary search in a recursive way. Let's see what's happening. Saying that the same function, the same array that we have, we still try to find the value of x equal to 16. So we pass the vector, we try to search the value of 16. And in the beginning, we pass the minimum index as well as the maximum index 0 and 9 over here. So let's see when that is called, and it will come to the function, understanding that it's not the base case scenario over here. Is going to go into the recursive function. So before we actually look into the code, I want you guys to see this code one more time. This is obviously a recursive function. Inside this recursive function, let me ask you, what is the base case scenario? There are actually two base case scenarios in this code. This is one of the base case, which means the item is not there. This is another base case. So when it hits the same value, we will return the index. Of course, the general case in this scenario has two of those. This is one general case. This is another general case. So this program is actually very interesting. That gives you two base case and two general case scenario. That's something you really need to understand when you look at a recursive function. So of course, the value that we're trying to find is not there, and therefore we need to use the first general case to help us search with a smaller range. And this time, so this is not the case, so we try to find the middle value. Index 0 plus 9 divided by 2 get the index of 4, so the middle value is 4. And since that is the case 1 scenario, what we will do is that we pass the same vector, call the same function, pass the same vector, same value that we are interested in. The low become middle plus 1, so it change to 5, and therefore we will have another runtime state that goes on top of it. And therefore what's happening over here is that it will try to look into the middle index between 5 and 9. Of course, it will give you the middle index equal to 7. At this time, you will compare with the value, understanding this is case 2 scenario that gives you the second general case. So you will call the same function, pass the same vector, same x value we are interested in, same low index. The high index will become middle or -1. So now you are looking at this index. And therefore, when that is called, we will look into the function, understanding that the middle value of between index 5 and 6 is 5, because again it's an integer division. So you will look into that one, finding, hey, this is actually the value we are interested in. So you will hit the base case scenario, return the value of 5. I want you guys to see this one. When that is found, 5 will pass back to where cause it. We will not do anything, we will not modify anything, simply pass that 5 back to here, and back to where cause it. So at this time, the whole purpose of this binary search recursive function is try to find that very index and then pass all the way back. Once we found it, we are not going to do any modifications over here. The whole purpose is that we want to hit the base case. Either it's not there or the value has been found and we can pass the index back. So I feel this is a very interesting comparison to look at the same problem. One is using a while loop, the other one is using the recursive way, and both of them are working very well. Gives you the answers that you are looking for. Recursive is considered as a divide and conquer problem. So we try to break the big problem into smaller problems. And while we are working on the smaller problems, we would be able to solve it, and hopefully we will be able to combine all the solved smaller cases back together and then try to find the answers for the major problems. Writing a recursive function code, once you are mastering it, is actually very easy, so that the clarity or the readability is actually very good, because look at the very condensed code talks about the different scenario, how do we solve the cases, and we try to break the bigger problem into the smaller. So usually the clarity or readability in recursive is actually very well. However, sometimes you need to pay attention to the efficiency. Sometimes, just like the Fibonacci example, it's actually not suitable to do it in a recursive way. And this is about the recursion. When we come to the next topic, which is sorting, we will see the recursive function ideas one more time. It's actually used in many different sorting algorithms.